So let's say that we have got this program from instruction 100 to instruction 107. All right, so from instruction 100 to instruction 107, and we have got data in memory from instruction 10, sorry, address 10 to address 23. So we have got memory from address 100 to 107, and we have got how many instructions there? 1 2 3 4 5 6, oh, sorry, 5. 1 2 3 4 5, and we have got data placed in memory and at another location from 10 to 22, and only these values are obvious. So हमें अब ये पता चल गया that how many instructions do we have. And as we know that computer is actually a sequential machine. The first instruction that goes to computer will be present at location 100. Okay? That will be present at the location 100. So as soon as the program is loaded, PC will have 100 in it. If you do remember from that fetch, decode, execute cycle, so the first address of the program is present in program counter. All right, now you might see a new register which is base register. I'll explain this on the go. And you now can see another index register which has got value 4 already loaded into it. So let's see how do we actually trace this program. Trace in terms of assembly language with respect to the fetch, decode, execute cycle. This is very important. Okay, so now as soon as this particular program loads, the address of first instruction, which is 100, is loaded into PC. From here, fetch, decode, execute cycle starts. From PC, this address goes to MAR, and then PC increases itself by 1. All right. MAR puts this address over the address bus. Address bus then goes to the memory and points to address 100. From address 100, the instruction LDD10 will be placed over the data bus, and data bus will deliver that LDD10 to MDR. Now from MDR, this instruction will be copied to current instruction register. This is fetch. From PC, address goes to MAR, PC increments itself by 1, MAR points to the main memory through address bus, and from that address, the instruction through the data bus delivered to MDR, and from MDR it goes to CIR. This is fetch. Now CIR will actually decode and execute it. So this is the instruction. Now in order to load directly from address 10, system will place this 10 in MAR. As soon as it places this 10 in MAR, now MAR with the help of address bus now pointing to address 10. From that address, the content 5 through the data bus arrives in MDR. I told you one thing, that MDR is the gateway of the microprocessor. So whatever from the memory, instructions or the data, when it arrives in MDR. But if it is instruction, it goes to CIR, and if it is data, it goes to accumulator. Okay, if it is data, it goes to accumulator. So now this 5, since it was LDD 10, so from address 10, it is directly loaded to the accumulator. One instruction is fetched, decoded and executed. All right. Now, this is one instruction. Now this 101 will go to MAR because now the new cycle, new fetch decode execute cycle will start. So this 101 arrives in MAR and PC increase itself by 1. This 101 arrives in MAR and PC increases itself by 1 because PC always holds the address of next instruction. MAR holds the address of current instruction. Now this instruction is being executed and accumulator has got 5 in it. Now this 101 will be placed over the address bus. Address bus will point to memory location 101 and instruction LDM3 will arrive in MDR through data bus. And I told you that LDM means immediate. Immediate means that we don't actually want any address to be accessed, but this 3 should be loaded to accumulator now. So this 5 will be replaced by 3. So from MDR it goes to CIR and then it is simply without accessing memory, the value will directly be loaded to the accumulator. Now this 102 will arrive in MAR and PC will increase itself by 103. Let's say it says LDX10 means that now it needs to use index register. This is the base address 10 and it will be added to the content of index register which is offset. So 10 plus 4 will become 14 and from address 14 this 8 will arrive in accumulator. Let's see how the whole thing happens. So address of the instruction from 102 arrives in MAR, PC increases itself by 1, 102 is placed over the address bus by the MAR, address bus points to 102. From 102, LDX10 will be placed over the data bus and it will arrive in MDR. From MDR it goes to CIR. So this completes what? Fetch. Now CIR will actually do the rest. Okay, CIR will do the rest. It will place 14 in MAR. Why 14? Because 10 plus 4 becomes 14. So CIR knows that the address from the data, from where the data needs to be accessed is actually 14. 10 plus 4. So this 14 will be placed in MAR. Now MAR is pointing with the help of address bus to address 14. So from address 14, this 8 will arrive in MDR. And from MDR, it goes to the accumulator. Okay. Now, this instruction is completed. Now this 103 will arrive in MAR and PC will make itself 104. So from 103, LDI 12 will reach to MDR. From MDR, it goes to CIR. Okay. And at address 12, what do we have? 22. So since it is LDI, this is indirect. System will place this 12 in MAR. From MAR, 22 will arrive. Then this 22 will be placed in MAR again because this is not the data. This is the address of the data. This was indirect command. So this 22 will be placed in MAR and from this address 22, now the content 50 will arrive in MDR and from MDR it goes to accumulator. Get the idea? That is how it works. Okay. So this is 2 instruction cycles This is one instruction cycle. This is second instruction cycle. This is just one instruction cycle. These are two instruction cycles. These are three instruction cycles. Do you get it? So these are three instruction cycles. That is how it works. Okay. So you need to understand in terms of this fetch, decode, and execute cycle. Sir, why does 102 has the data of 14? Shouldn't it be 10? But if 102 is LDX, indexed addressing. Indexed addressing. Indexed addressing means that this address will be added to the offset in index register. So this X means that the utilization of index register. So this 10 over here will be added to this 4, will become 14. 10 plus 4, 14. This is base address, this is offset. 10 plus 4, 14. Then this 14 will be placed in MAR, and from 14, what do we get? 8 in accumulator. LDX is not direct. So you got it? Okay. All right. So if you want to load this 10 to accumulator, then you would have to use LDM command. All right, beta. Good. So this is how we actually do the whole thing. This is called tracing. All right. Sometimes they just want you to tell what is in accumulator after the execution of command. Sometimes they want you to show every single step of the fetch, decode, execute cycle. I hope that fetch, decode, execute cycle would have become clearer to you now. ठीक हो गया? All right. Now, pay attention to this. This I have copied from the book. What we have just done is absolute addressing. Absolute addressing means we actually refer to actual addresses. We actually refer to actual addresses. Hold on. So, अब अगर आप देखें तो ये 3 तरह के मोड्स हैं. ये एड्रेसिंग मोड्स की हम बात नहीं कर रहे हैं. ये एक्चुअली हम इस तरह बात कर रहे हैं like how do we actually can address to the locations in the memory. So there are 3 ways. So what we have just done was absolute addressing. What was it? Absolute addressing. So this says that LDM 0 means accumulator would have 0 in it. Store means whatever the content of the accumulator, store it at this address. So at address 210, now what we have 0. So LDM, LDX, LDI, LDR, whatever that starts with L means it is loading. Store is the command that takes the data from the accumulator back to the memory. As I told you that data bus is two-way. It can bring in the data and it can take it out. So store, when the data is processed, it is finally placed in accumulator. Store takes it back to the main memory. So you just loaded 0 to accumulator, and that 0 will be now saved at address 210. Then this is LDM42, means load the value 42, load the value 42 at in the accumulator. All right. So what out does we will discuss later. LDD 210 means load directly from address 210. So 210 from address 210, this 0 will be loaded to what? Accumulator. We will discuss increase afterwards. We will discuss store afterwards. Compare afterwards. Jump if not equal afterwards. And then the program ends. Here the concern is not the tracing. Here the concern is how do we actually access memory addresses in the address part. We are not concerned with this opcode, but with operand. So here you can see that we have used actual addresses. This is called absolute addressing. So this is address 210, so we have used 210. This is 210, this is 210, this is 202. So this we have used 202. In symbolic addressing, what basically happens, that we name the addresses, like we name the addresses in our languages, X, Y, variables. So what are variables in the languages? In high-level languages, variables are the names of the addresses. Over here, that is exactly what has happened. This address 200 is now named as start. How do we know that this is the name? Because of this colon. All right. So this 202 is now called loop because it is with colon. This is 210. This is now called A with colon. So this, we don't call them either name or variable. In low-level languages, we call them symbols. So over here, what is written? Store at 210. But over here, what is written? Store at A. Store in A. So it will be saved here. Exactly same is happening, but the difference is that over here we were using absolute addressing, and over here we are using symbols, the names of the addresses. All right. So load from A, store at A, jump to loop. So this is loop. Over here, what is written? Jump to 202. Over here, we have named 202 as what? Loop. So this is called symbolic addressing. Then comes the base relative address with the help of base register. Now what is base? Base register holds the address of first instruction of the program. Base register holds the address of first instruction of the program. In computer system, as soon as a new program is loaded, the address of first instruction is loaded into the base register. The address of first instruction is loaded into the base register. So base register would have 200 in it. No matter how big the program, where the program is currently, which instruction is being executed at the moment, which memory address is being accessed, the base address would have the address of the first instruction of the current program, no matter what. So the first address of current program's instruction is 200. So base address would have 200. Now it says that store at the value of the base register. Remember that thing which we discussed, micro commands with reference to, what do we call it, in fetch decode execute cycle. We did it with this mathematical form. What do we call it? It will come to mind. Anyways, so this is a bracket. Bracket means the value of base register. The value of base register is 200. 200 plus 10 will become 210. So 210 is this. So store at 210, store at base register plus 10, it is same. Store at A, it is same. These are three different ways accessing the memory locations. This is called base relative addressing with the help of base register. This is called absolute addressing. We use the addresses as they are. This is called symbolic addressing, where what we do, we actually name the memory location. So when a program is loaded, first instruction is regarded as instruction number 0. Second one is called 1. Third one is called 2. So this is base address 200. So if it says that 200 plus 10, so basically this offset from the base is 10 over here. All right, so base register would have what? 200. 200 plus 10 becomes 210. So the first instruction itself, the 200 address itself is regarded as 0, and then 201 is regarded as first, and then that is how it goes on. So base register plus 10 means 200 plus 10, 210. Over here, base register plus 2 means 200 plus 2, 202. So basically you are wanting this program to go back, to jump back at 202. So this is base register plus 2. So base register is 200, so it would become 202. So all these three techniques are the same. Their result will be same. Only the approach, the way they are accessing to memory addresses is different. So it might be absolute addressing. 99.9% questions that appear in AS for tracing, they use absolute addressing. Few of the topics will require you to know the symbolic addressing as well, but I have not seen any question in the past papers related to the base register or relative addressing. So this is called relative addressing. This is another mode of addressing, like direct, indirect, indexed, immediate, and relative. So this is relative addressing, relative to the start of the program. Relative to the start of the program. So relative to the start of the program plus 10, relative to the start of the program plus 2. So start of the program's instructions address is saved in base register. So what base register has, whenever the new program is saved, its first instruction is always saved in the base register. So